Hello everyone, I'll be doing my next Java tutorial. Currently right now I deleted all the node class that we had in here in our main program because we're going to make it much easier for ourselves to be able to um, add nodes instead of having to do the whole make a node, then add that node that returns another one and all that complicated stuff. If you can hear noise, I apologize. I really wanted to do this. So forgive me. So what we're going to do is we're going to make our public method that's going to just add nodes, and later on we're going to go and make it a bit nicer and figure out how to retrieve them and so on and so forth. So what we're going to do is we're going to do a public void add node uh, node node. Okay, and because this is static, meaning that anything in this method can have access to it, we're going to do when we make this method, we're currently going to equal this to a new node with a value of nothing, a value of 0. Okay, so when we add our node, we're going to do current dot next equals our node. Okay, and this is giving me a value because fail. Node dot add current dot node, and then current is going to equal this node. Actually, current is going to equal current dot next. Okay, and what this is going to do is when we add this node, right, we're going to be assigning the next node after that we're adding to the one that we're assigning to. So when we add this node, right, we're making the current's next node equal to the node we added, and then back here we're just saying, okay, now our current node is going to equal the one that we just added. Okay, so now if we do adding node and we do node class dot add node, or actually let me just do this. Public static. Okay, so now we're going to go and do current value is, and then current value, and hopefully if we print this out we get the current value is 1. Awesome. Now watch what happens if we know this works, because if we do current dot value now, let me print this out. We're going to get 0, right, because it's the head, and then current value 1. Okay, and now every time we want to add a new node, all we have to do is just add node and then the node we want to make. Okay, so that's a very easy way to add nodes instead of what we were doing before, where we would add a node and then it will reassign, it'll do node, right? And the reason why this works is, well, actually there's a much better way. We just have to do current.addNode, which returns a node, and right now we have current. Okay, so no, actually this works, because even though current.addNode is returning the next node, right? Actually, we can just do that. Current equals yeah, it still works, because current.addNode returns the next node, and we're sending that now to its current node that we're on. Now, what happens if we want to remove the last node that was added? All we need to do is public void remove, and we're assuming that when we remove, we're removing the last node that was added. Later on, we can go and say, okay, we're going to have an index, and we're going to remove some value that we want. So right now, we're assuming that we're on a current node. We're going to do current. Well, we need to get the node before it and set its node to null. Get its node and get the next node that it has currently and set it to null. That way, when we go after that, we don't have any nodes. So we're actually going to now need to do public node before. Okay, so when we add a node, we're going to do this dot next equals next, and this dot before equals. So when we add the node, we're returning next, right? So this dot before equals this, meaning that we're assigning this class as the before, because remember we're returning next. So public void remove, we're going to do before this dot before dot next equals null, and actually we're going to be returning a node. Return this dot before, and hopefully we should get it to work. So now remove node, and we do now current dot remove, and now remove node. Let's print out where our current node is now. Hopefully. Okay, so this means that we weren't able to remove the node because let's see, when we added a node, let's do here what the node before was. Node before this was the node dot next, node dot next dot before is going to equal this. So actually, no, before this was, we're going to print out the value. So let's do this dot next dot before dot value. Okay. So when we added the node before the node we added was 0, the current value is 1, and now that we removed the node, the current node value is now back to 0. So that's how we removed the last node that was added. Okay, so again, let me go over this just in case some of you got lost. When we add our node, right, we're going to set the next node, right, to the one we added, and the next node that we add, we're going to set its before value to this class. So let's get paint up here. So we have a node, right, that leads to another one. Okay, so what we did was, when we added our node, right, we're setting the node, we're setting this node, right, let's do 0, 1, we're setting the node that was before this to the one we're currently on, right, and we're setting this node's, the one next after it, to this one, obviously, right. So when we remove, all we do is we make the current node this one and make the node after this null, right. So now we're back to here and we have nothing after this, we have nothing after this one, right, because this is now null and void, so there's nothing here anymore. Okay, so that's pretty much it. I want to see how much we're on time. 12 minutes. I think we have enough time to add the remove statement on which one we want to remove. Okay, so public node, and we're going to call this remove as well, but we're going to be adding a parameter. We're going to be adding the node index, right? So we're going to need the index that we want, and what we're going to do is we're going to, let's say we have let me erase all this. Okay, let's say we have a node, right, another node, and one other node. Okay, so what we're going to do is, let's say we need to have at least 3, right? We have to have like some middle one, right, where if, let's say, we want to remove this one, right, so let's say this is 0, 1, and 2. Let's say we want to remove this one, we're going to do remove, let's say index 1, and what this is going to do is it's going to set the node before it's next to this dot next, and essentially now we're cutting this out, right? We didn't even have to remove it, we're just cutting this out of the middle, that we're cutting out the middleman. Okay, and essentially this is a cool way to that's why linked lists are awesome, because it makes it you don't have to iterate through a whole list. You could just get the one you want, remove it, and set the one before it equal to that one, and now 0 goes to 2 when we do this dot next. Okay, so hopefully that was a very easy explanation, and programming is pretty much going to be just as easy. Okay, so what we need to do is get how many nodes there currently are, right? And that's easy to do. All we need to do is do a for loop, or actually a while loop. While node, and not only do we need an index, we need to have our starting head, node head. While let's do current equals head, while current dot next does not equal null. Let's say how many we have. So we need to do int I. Well, let's say int index number, right? The number of indexes we have equals 0. We're going to do index num plus plus. Okay, so currently we're just going to return null, just so that way it runs. And what we're going to do is, once that runs, we should print out to make sure how many nodes we have. So let's do number of nodes are index num. Okay, so we're not going to remove any nodes, we're just going to add. Right, so when we run this, fail, we do remove node, and let's just do 1, and our head will be let's do public static node head equals current. That way when we first make the program, we already have a head node. Node head, so oh, not remove node, just remove. And actually, this should not be here. Actually, yeah, it should be. We just need to do it in here, that way we don't have to go through our classes. Public static void remove node int I node head, and then let's do remove node dot remove actually yeah, no, this should be in here. Okay, so current is going to equal the head, but actually now we don't need the head anymore because we already have our head. So current equals head, while current.next does not equal null, index plus plus, number of nodes are. Okay, so now we can do remove node. It's not applicable. Oh, right. So we run this, we should have that's interesting. It's not printing out number of nodes. How about remove node at index, and let's change this to node at. Oh, that's why it's still running for some reason. Oh, fail. Then current equals current dot next. Fail. Alright. So the number of nodes actually should be 1 because we have one node already. Adding node. Alright, so we have 2 nodes, right? So let's say we want to now remove the node at int 1. We just need to do now while we have our int position we want to do, so let's do again current equals the head node. Okay, then for int I equals 0, I is less than int, that's not a good idea, int position equals 0 equals 1, there we go. Int I is less than index num I, not I position. And what this is going to do is this is just going to get our current to the position that we want. Position plus plus. Okay, so now let's do current equals current dot next. Okay, so if we're at 1, right, and we're adding, right, so that's where we want to remove the first position. Let's see, the first index, right, so 1 is going to goes 1. Okay, and then let's do current dot remove. And now current equals, well, now we have to do current. When we do the remove, we have to do current dot remove, which will return the last thing. Actually, current dot next equals actually let's do before. Let's make a node called before equals how can we do this? Because when we remove, we set the one after that to null, right? So we can't set it to the one after to null because there might be something after it. So we need to set the current dot before equals current dot next. Here we go. And now that should have essentially just removed the value. So now let's do current value is that value, and to make sure that this works, the current next value is okay. What are we on time? Okay, 25 minutes. I know this is a bit long, but I want to actually do this, so we have to say if the index when we're doing this, because we need to at least have something that comes after, right? Then we can do all this else. Not enough nodes to run this method. Please use the method remove node. Okay, so now if we run this, as you can see, there's not enough nodes, so let's do add node 2. Let's see if this now runs it. So the current next value, so it didn't seem, we got the current value equal to 0, which makes sense. Okay, so oh, that makes sense. Let's do remove node 2. That's interesting. The current value is 1 and the current next value is 2. So it's probably an issue with our for statement. So our position is 1, right? And it's less than 2. So current equals the current value dot next. So the current dot next of that is going to the current before that one. Actually, current dot before dot next. So we'll actually skip. So now, hopefully, if we run this, and now current equals current dot before. There we go. So what this does is the current dot before dot next value, right? So the current ones before value, right? So we're getting this one dot next, meaning the one we're setting the next value after, is going to equal this, right? And now what we're doing is we're just setting the current node, right? We're still on this node, right? We're still on this one. We're going to set the current value now to this, and that's pretty much the end of it, right? So now we've set up our removing nodes as certain indexes from not 0 but from 1, right? So currently we want the first node, which will be the head node. We just do 1, but we can't remove the head node, right? We'll in probably the last tutorial we'll go and work on removing any node in any position, either it being the head or the tails or somewhere in the middle. Thank you for watching. Please thumbs up and please subscribe. Also comment on what you would like to see next.